Hello everyone, this is Kyriakidis and Katsikas, and this is our project for the first assignment of computer applications. Our project basically is divided in three parts. The first one is about parsing the XML file. The second one is the creation of the database and the calculation of the admittance matrix. In each part, as you can see, there is developed in a small GUI. For the parsing of the XML file, the GUI actually allows the user to choose between the two files, the SSH and the EQ file that wants to parse. When it does, it actually stores the file into a predefined txt file, which is in this case a safe directory that in the next phase, when the directory is closed, it creates a buffer reader to read the contents of the txt file, which in this case there are the two directories that are the directories of the two files that we want to parse are stored. So after this point, and when the buffer reader is closed, we create two objects, the read XML and the SSH object that handles each of the two files that we want to parse. In the second part of the GUI, it is for the SQL database that creates a small frame that allows the user to input its credentials, the username and password, and the database is processed only when the correct credentials are placed. And the last one is a small table GUI that takes the admittance matrix that we have calculated and makes a small presentation of that. For the GUI table, we have made some settings here. We have specified the dimensions. We have specified the font that we want to use. And for the login to database, we create the two panels for the username and the password. And we have created a small button in this case that. When it's pressed, when the credentials are correct, it allows the user to continue with the database. When the credentials are false, it resets them again and allows the user to do it again. So a small presentation of that. So we can see here is the directory that we have created. Okay, so here's. So we take the two files that we want. So in here, as you can see, it has created the files. Here is the output of the admittance matrix, and if I put my credentials wrong and attempt to login, there is an invalid message. And if I cancel, it closes the program. And for the next part, Haris will tell you about the parsing of the XML file.
Okay, right after browsing the files like Avram did, we're gonna parse all the CM objects with the data requested from our files. Here in this class, you will see that we will read in this point of the code, we will read the files, and after that we will have to create a method that will consist of all the nodes with a specified name. based on the name of the node list, the method extract node from EQ file will take an array list and will store inside all the different information that we need. Take for example base voltage. We only need its RDF and the nominal value of the base voltage. You can see here we add these elements at the array list as I just told you. Going back to our main method, you will see that we have created two different array lists, the base voltage and the SQL base voltage. This will not concern us for now. It will be only used for our SQL database. The same procedure as the base voltage will be followed for every sim object. However, there are cases that the children nodes of a parent has attributes that we want to store in the array list. So at that time we will call this method, the method in which is here, the method getRelatedElements. So what it does, it gets the tag name of the child node and the parent. It goes through all the child nodes, and if the tag name matches the specified one, then it will turn the ID. We have marked a Boolean variable flag here. The only use of that is that sometimes when running the program we had some conflicts, so in order to avoid them we used this variable. Going back to our main method, you will see that in some cases we had to import data from both SSH and EQ files like in the synchronous machine. We have created two different array lists, one that will extract the data from EQ file and the other from the SSH file, and we will call then the method join array lists, which is you can find at the end of our code. If you see here what this method does, it take both of the array list from EQ that we have obtained from EQ file and from SSH file, and then he will try to find the IDs, and when the IDs match, he will store the matching IDs from SSH list to the EQ list. Going back now to our second part of the assignment, how we create the database. So in order to create a database, we have first to create an object for our class createDatabase. After creating the database, here at our constructor, you will see that we create the database in this string, the SQL string, and we successfully connect with this set statement. Going now to the create data table method, in this method we create all the tables that will contain the array list that we just created at part 1. And then with our insertInTable method, we will store the array list with the acquired data in the stated tables. The stated tables are here. We have also used the updating table, the delete from table, and the select from table methods in case we need to add new values to print tables or to remove anything that we want. Now we take, for example, in our main method, take for example a base voltage. It contains of two columns, the ID and the nominal value, and we create here the data tables with the ID and the nominal value, and then we insert all our acquired data in the SQL base voltage table. So last but not least, in this second part, I have to mention that we implemented the rational database, implementing foreign keys that will give references to the according tables, as you can see here in our nominal voltage.
So for the last part of this project, we will try to calculate the Y-bus admittance matrix. Mainly for the calculation, we will use two array lists, one for the connectivity node that stores the ID of the connectivity node and the conducting equipment, or only for the connectivity node, and one for the terminal that stores the ID of the terminal and conducting equipment and connectivity node. Basically, our code is divided in parts. So for the first part, it's the preparation part, where we create an instance of the object calculate Y bus matrix, and in here we will. At first, we will check the breaker state, which is a method that checks if a breaker is connected, if a breaker is closed, and if it does not, it removes it from the list. The same happens for the check connectivity terminal, that checks if a terminal is connected. If not, it removes it from the list. So for after this part, we use the first class here for the breaker and the second one for the connected terminal. So our primary goal for the Y bus matrix is to create the buses of the grid. So for the first step, we will try to group the terminals based on the connectivity node. For this case, we call the function group terminal by connectivity node in our calculate Y bus, which basically it checks if the terminal has the same connectivity nodes. It groups them to one array list, which is called group terminals, and then it in the group list, and then it returns the group list back to the main method. When this happens, after this point, we will go to the next step, where the condition of the breaker will help us further group the terminals that exist in our system. So we go back to the calculate Y bus matrix, and in this method, group terminals by breaker, basically it checks for the first terminal and finds the first terminal in one group of terminals, and then checks the second terminal of the breaker to another group of terminals. If there is a connection, adds the second part, the second group of terminals to the first one. As a result of this, we will have a total number of buses, which is stored in the grid buses, which is actually a group of terminals that are connected between each other. After this point, we will mainly focus on this part of the main method, where we at first place the Y bus matrix, the admit matrix here with all zeros, and in the second point we will add first the lines. Basically, this part of the code takes the line ID, and with this method get terminals from ID, takes the two terminals of the line. So at first takes the first terminal, and if it finds in one group of terminals, it stores the index 1. And for the second part, when it has found the first terminal, it goes to this part of the code, checks this method object connected bus, and if there is somewhere connected the second terminal of the line, it stores to the next index. And after this point, we calculate the base voltage line from this method in the calculate Y bus matrix, where in here it takes the element of the specified terminal, the base voltage that contains the RDF ID and the voltage value, and the voltage element which is the IDs, the element ID and the base voltage ID. So it makes a comparison and finds the appropriate value from the base voltage. In the next part, and for the final part, adds the line admittance and the shunt admittance to the Y bus matrix. For the next step, it adds the admittance, the shunt and line admittance of the windings to the Y bus matrix. Basically, it takes the transformer ID, takes the windings from the transformer ID, and searches the group of terminals to find the first winding. When it finds the first winding, stores the index. For the second part, finds the second winding, stores against the index, and we will calculate as we have two different base voltages in here, we will calculate for the base voltage 1 and 2, which correspond to the first and the second winding of the transformer. And for this place, we will add again the line admittance and the shunt capacitance. It should be noted that only the line admittance is added both in the diagonal and non-diagonal elements, whereas the shunt admittance is added only to the diagonal elements. And after this, we will call the GUI, and the GUI will get the output of the transformer as you saw before. Thank you for your attention, and this was our project.